Okay, so we're on 8-6. We're at the end of the chapter, and we've spent the entire chapter factoring and learning how to factor. It's a very important thing for quadratics and algebra and solving and figuring out solutions. So let's review. We started with GCF, greatest common factor, and we could use that for any number of terms. So we can just always check to see if there's something you can take out of, the number of terms that you have. Grouping, we did grouping, and that was only used when you have 4 terms. So if you don't have 4 terms, that's a bad choice. Box 1 we're going to use when there's 3 terms and when there's what? A 1 before the x squared, when it's just an x squared. And I'm just going to leave it as an x squared. And for the box 2, it's going to be when there's something before the x squared, a number of some sort, like let's say a 5 or something. Then we're going to use box 2. So those are kind of the difference between those two. Then we got the perfect square trinomial. That is also when we have 3 terms, and we have the 4-check system. 4-check system, or otherwise known as the smiley face. And then we have the difference of squares. That's a 3-check system. So just little things to try to remind you of what we talked about. But part of the battle is always figuring out A, which of these methods should I use, and then B, is it completely factored, or could we keep factoring? So just because we may get a parenthesis doesn't mean we're done factoring. So number 1, always, if you're looking to see if something's completely factored or you're starting to factor, you should always check for a GCF, because that one you can use in any problem. So you should always first start with that, no matter what. So let's take a look right here. Tell whether each expression is completely factored. So as we can see, it's somewhat factored, but the question is it completely? Is it done? If it's not done, then keep it going. So right now we have a 3x squared times this whole parenthesis. But when you look in that parenthesis, do you see a GCF inside the parenthesis? The answer is yes. What can you factor out of both of those terms inside? You can take a 2 out, can't you? So don't worry about this, that we have this in front. That's okay. It's that, and it's going to be times. These are all multiplied. And then we'll take the 2 out front. And if I factor out a 2 out of 6x, what do I have left? 3x minus, divide that by 2, and I'm left with a 2. So now I've got this 3x squared. I've got the 2 that I took out, and then it's times this 3x minus 2. So we can now combine these. These are 2 different things that we can just put together because it's a multiplication. So 2 times the 3 is 6x squared times 3x minus 2. So what did we use to keep factoring that? What was that called when we took out that 2? Because we're going to write the methods right by it here to help us. We use GCF. Okay. Look at B. What do you think about B? Now you got 2 parentheses, so you got to look in both. 2x plus 6. Anything you can take out of 2x plus 6. There's 2 terms there. That's right. You can take out a 2. So if I take a 2 out of this one, right here, what do I have left? Divide that, and I'm left with just the x, plus 6 divided by 2 is 3. How about the x plus 5? Yeah, there's nothing else we can do there, so we'll just tag that along. And that is our final answer. And what did we use right here? Again, we use GCF. So always start trying GCF. Okay, let's look in these 2. X squared plus 1 and x minus 4. Is there a GCF? No, there's not. Oh, but is that a difference of two squares there? Yeah, that's a perfect square, and square root of 1 is 1. So isn't that the difference of squares? No, it's not because of that, right? That's an addition. That's a sum of two squares. That's not a difference. So we can't use that. And there's no other solving technique that uses two terms other than difference of two squares. So GCF or difference of two squares are the only thing I need to check there. There's nothing else. It's completely factored, and that's how you can write it. And this is the hard part, is kind of figuring out, well, which ones are and which ones aren't. So look at the next one. We see a trinomial, 3 terms. What do we do first? GCF. Okay, so look there and see. Can I take anything out of those 3 terms? Got to be able to take it out of all 3. Yeah, I see a 2. I don't see anything else because there's not an x in all of them. So let's do the 2. And we're left then with a 5x squared plus 24x plus 16. That's using GCF. Okay. Well, now look inside of it, because again, a lot of these times you're going to use more than one thing. So this isn't necessarily done. Up here, these were done. They were 2 terms, and the only option for 2 terms was difference of 2 squares, and none of them fit the bill. Okay. Well, here it's 3 terms. So we have some options. It could be a perfect square trinomial, which I will say no to right off the bat because that's not a perfect square. 5. 5 is not a perfect square. But then we go up here and we have the box 1 and the box 2 to look at. Which one would this be? That's right, it's going to be an option for box 2 because there's something before the x squared. So we're going to set up our box. What plus what equals what times what equals. And what numbers do I put in there? Yep, I put the 24 in here, and then 5 times 16. Let's go up to this side. What is 5 times 16? That's 80. Okay, and then we need to think of factors of 80. 1 and 80. 2 and 40. 3 does not work. 4 and 20. Ding, ding. That's going to work, isn't it? So 4 and 20 will fit the bill. And remember, box 2 doesn't mean we stop there. It means we are going to rewrite that middle term with 4x and 20x. So I'm just going to leave that 2 out here. And then I'm going to rewrite this 5x squared, and instead of the 24x, I'm going to put plus 4x plus the 20x plus the last term, which is 16. We're grouping now. So we go in and we put our parenthesis around it, because there's how many terms there? 4. 1, 2, 3, 4. 4 terms, grouping. So we're using GCF, box 2, now we're grouping, which is part of box 2 really, but lots of skills in this one thing here. So 5x squared and 4x, what can you take out? Take out an x. 20x and 16, what can you take out? 4. All right, so we're looking and we're noticing that we have those 2 kind of bigger things right here. And those are the same. So I've got the 2, let's see, I'm going to take the 5x plus 4 out, cross it off. Now we're going to see what's left. X plus 4 goes in our other parenthesis. All right, anything else? No, those are two terms, and so they either are GCF or difference of squares, and nope. So I can remove the bigger bracket and just leave the smaller ones in there. All right, let's try another one. Okay, what's the first thing we try? GCF. Is there a GCF on these? Heck yeah, there is. So we've got the 8 and the 18. What can you take out of both of those? Yep, we can take a 2 out. What else? X to the 6th, X to the 2nd. Right, the smaller one. Y to the 2nd, Y to the 2nd. Well, they both have a Y to the 2nd. Put your minus in there. So 8 divided by 2 is 4. Now if I took 2 x's out, I'm going to be left with 4. And I took the y squared out, so it's not there anymore. It's gone. 18 divided by 2 is 9. X squared I took out. Y squared I took out. So there isn't anything else there. I'm going to slide that closer. I don't like it way over there. I don't need that space. Okay, so that was using GCF. Now what? Well, we again got to keep going. That's the thing with this. A lot of us go, okay, done. No, always double check. Look inside of here. How many terms? 2. So again, we check GCF to make sure we didn't miss anything. No, there's nothing for GCF. What's the only other thing that had 2 terms? Difference of 2 squares has 2 terms. Let's see if it is a difference of 2 squares. That's the 3-step check. Is that a perfect square? Yep, 2x squared. Is that a perfect square? Yep, 3. Is that a subtraction? Yep, it definitely is. So this is a situation where you have a difference of perfect squares. So you are going to have these two numbers, one added, one subtracted. So 2x squared plus 3 and 2x squared minus 3. And now you should be yelling at me to make sure I don't forget what? That. And double check again. I mean, I went a little too hasty. You should double check again. First of all, it's an addition, so it's not going to be difference of squares. And there's nothing you can take out. This is a subtraction, but this is not a difference of squares. Square root of 3, no. Square root of 2, no. So what did we use here? We used difference of squares. All right, we got another one here. 3 terms. Okay, what's the first thing you always do? Ding, ding. GCF. So go ahead, feel free to stop the video or whatever you need to try these before you see them all written out. Let's see, what can you take out? Oh, geez, you can take 3 out, right? And we got end of the 4th, end of the 3rd, end of the 2nd. So what can I take out? It's got to be in all 3 of them. That's right, they all have at least 2. So, plus, let's see what's left here. 3 divided by 3 is 1. And then if there's n to the 4th and I took 2 out, that means I have n squared. 15 divided by 3 is 5. If I had 3 of them and I took 2 out, that means I have 1 left. 12 divided by 3 is 4. And if I took both out, then they're both out. I'm going to again move that closer. So that was using GCF. Now look inside. What do you have? How many terms? 3. Okay, so what are options for 3? Could be a perfect square trinomial. That's possible. Could also be box 1 or box 2. So you can do either. I think I would personally see that there's a 1 here, and box 1 is so simple that I would do box 1. So what plus what equals what times what equals, and it's going to be a -5 and 4. Can you think of that? Well, there's only a couple options. It's 1 and 4 and 2 and 2. So 1 and 4 seems to be the only one that could give us this possibly. Obviously, it can't just stay at 1 and 4 because 1 plus 4 is a positive 5. So in order for it to be negative, they both would have to be negative. Does that work on the bottom? It does. See, this is where it's really, when I was pushing the signs, understanding how signs work, it's so important. So that's done. So that's going to be n minus 1 times n minus 4. I just dropped those in, and again, don't forget that. And if you're going to forget it, if you think you're one of those people that just forgets those things, highlight those that are sitting out front so you don't forget them later. And then this is box 1. And when you look at this too, you should check again. Nope, there's no GCF, and they're not a difference of 2 perfect squares, because that would have to be squared for that to happen. The 4 and the 1 are, and they're both minus, but these ends aren't. Okay, so that's that, and we have even more practice. So again, use this however you need to use it so that you can learn how to do these. Maybe try the sheet and then watch it. Yeah. Okay, first one. We're looking at it. There's 3 terms. First thing you always try is GCF. What can you take out of it? We'll try GCF. 12, 48, 4. Oh, we can take a 12 out. Then we have a b to the third, b to the second, and b. So we can take, they all have at least 1. Let's see what we have left. 5, 12 divided by 12 is 1, and I had b to the third. I took 1 out, I have b to the second left. Plus, 48 divided by 12 is 4. I had a b to the second, I took 1 out, so I have 1 left. 48b divided by 12b is 4, because the b is out front. All right, great. Not done yet. That was using GCF. Now I have to look inside again, and I see it's still a trinomial, and it has a 1 before it. So we can try what, guys? Box 1, or it could be a perfect square trinomial. So 4 and 4. Can you think of 2 numbers that multiply and add to 4? Hopefully you got that one quick. 2 and 2. Right. I'll highlight that so I don't forget it. Write this, b plus 2 and b plus 2. It was a perfect square trinomial. And 12b goes in the front. You could write this times b plus 2 squared. That would be fine too. Either way is completely fine with me. All right, then we have another trinomial here. Again, first step, always, always, always GCF. I didn't add box 1 here. We have 2. Almost all of these have a couple methods. So unless it's completely factored. Didn't we have one of those? Yeah, this one. Okay, so do you see any GCFs in here? 4. 4 goes into 72 18 times. Okay, and no other y's. So divide that by 4, you get y squared. Divide that by 4, you get 3y. And divide that by 4, and you get the 18 right here. Looks like we are looking inside at 3 terms again. We are noticing there's a 1 before the y squared, so we're going to try box 1. Three and negative 18. GCF, box 1. 1 and 18, 2 and 9, 3 and 6. That might work. Let's try that. 3 and 6. Well, to be negative, one of those has to be negative, and for this to be positive, it's going to be the smaller one that's negative. So it does work. All right, good. So we're going to write n minus, oh, it's not n, is it? It is a y minus 3 and a y plus 6. And because I highlighted that 4, I won't forget it. All right, let's look at the next one. Two terms. So we only have a couple options. GCF or difference of two squares. So let's start with the GCF, because is there anything you can take out of both of these? Well, heck yeah, you can take out the x squared, right? If you took out an x squared, that's the lowest one between the two. You have an x squared left here, minus a 1. Oh my gosh, help me, heaven help me. That was my husband sneezing and scaring the living lights out of me. Okay, anyway, now we're not necessarily done. So that's GCF. But what we have to do is look inside of here again, and it's still two terms. So we still have either GCF, which we don't have anymore, or the difference of two squares, which is the 3-check system. So let's go ahead and check those. Is that a perfect square? Yeah. Is that a perfect square? Yeah. Square root of 1 is 1. Is that subtraction? Yes. So it definitely is a difference of squares. And when you have that difference and no middle term, that meant you had one of each. You have x plus 1 and an x minus 1. And I should have highlighted that so I don't forget to bring that down. That should not be, that should be at the same level as those. I don't know why I wrote it lower. Okay. So that is perfect. No, it isn't. It's difference of two squares. How about that? What should you try first? GCF. I mean, do you see how often this comes up? GCF has been in almost every single problem. You can take a 2 out. x4 plus 9. Okay. What do you think? Look inside there. There's two terms. What are you going to check? You're going to check difference of two squares. Let's check. Is that a perfect square? Yes. Is that? Yes. And that is a positive. That's got to be a negative. It has to be a difference. So we can't do that. So this is my final answer. So I did factor it a little bit. I had the GCF, but I cannot go any further because it's addition. If it were subtraction, I would be able to go further. All right, so we got 2 more to go. Again, when we look at these, we see 3 of them. We try GCF right off the bat. 2, 10, and 12. Yep, we can take a 2 out. P to the 5th, P to the 4th, and P to the 3rd. What can we take out there? That's right, we can take out a P to the 3rd. Now, divide 2 out, and that's gone. But if it's P to the 5th, and I took 3 out front, then I have P to the 2 there. Okay? Plus, 10 divided by 2 is 5. And I had P to the 4, and I took 3 out, so I'm going to have a P. Minus 12 divided by 2 is 6. And I took the P to the 3 out front, so there's none left there. Oh, look at that. It's a trinomial with the 1 in front. So we're going to try box 1. So what plus what equals, and what times what equals. And let's see, what numbers do we have here? We got a 5 and a negative 6. Can you think of something that would work there for a 5 and a negative 6? So it's 1 and 6. That might work. 2 and 3 also might work. Let's see, we need to have a negative here. That's going to be a positive 5. I'm guessing we're going to use the top one, 1 and 6, where this will be a negative, because then you're going to get the negative 6 and a positive 5. Okay, that's done. Oops, I'm highlighting this so I don't forget that. And I didn't write here. This is GCF. And I get P minus 1 times P plus 6. I bring that down and I have 2P to the third. So that was using, again, box 1. There's nothing else we can simplify in there, so we are done with that. And we have one last problem. So go ahead and try that. You should pause the video and try to give it your best shot here. I see GCF again written all over this. We got a 4 and x to the third, x to the second x. So I can take at least one x out. Let's see what's left. Divide that 4 out and we're left with x squared. Divide the 4 out and we have a 4. And take one of the x's out and we have x. Plus 16 divided by 4 is 4, and the x is pulled out front. So I'm going to highlight this one again because I don't want to forget that that's out front. And we're going to go ahead here and see, oh, this looks like a perfect square trinomial, guys, is it? Let's see, x, 2, check, smiley, times 2, 4x, check. Put the nose on. Put the ears on. Put the top hat on. Bring down the 4x. See? It's a nice little thing, isn't it? So there we go. So we used perfect square trinomial. What else could you have used here? Yep, you could use box 1. So we used GCF and then perfect square trinomial, but you could have used box 1 and got the same answer there. Hoofta! So hopefully that helped you, and we'll see you next time.